Hello students, here I have come with a new topic, coordination compound. I have selected 10 solid questions from the previous years. If you go through this question, if you watch this video and understand this concept and this question, this video will take your preparation of the coordination compounds to the next level. So we'll go ahead with the topic. Stay tuned till the end of this video. So over here, the first compound they have given, you have to write the IUPAC name for this. So IUPAC name, so the rule is very simple. Whatever comes first, you have to write that first. Means over here, the compound given is potassium. Sorry, 3 potassiums are given. This is aluminium. Ligand is C2O4 means oxalate. Okay. So whatever comes first, you are writing that first. Means over here, you are writing it this way. So name of this compound will be potassium, because this is the counter ion which is outside this coordination sphere. Outside this coordination sphere is the counter ion. You are writing that first. And again, don't write this as a tripotassium because 3 potassiums are there. Whether it is 1 potassium, 2 potassium, you are just writing potassium, because that is understood when we write the oxidation state of the central metal atom and considering the charges on the ligands. It is understood how many potassium you are going to put. So over here, this is the potassium. Now comes the coordination sphere. In coordination sphere, we always name the ligands first. Remember this. In a coordination sphere, coordination sphere means in that square bracket, we name the ligands first. Then central metal atom. Ligands can be more than one. If it is more than one, then we name the one which is coming first in alphabetical order. So over here, there is only one ligand which is oxalate, and since it is negative ligand, we will be calling this as a oxalato. How many are there? There are 3 ligands like this, trioxalato. Now aluminium. Now the question comes is whether we are writing aluminium or aluminate. We write aluminate if the coordination sphere is negative. In negative coordination sphere, aluminate. Or if it is a chromium, then chromate. Means we add this 8 at the end if the coordination sphere is negative. So coordination sphere, negative coordination sphere. And this is as it is if it is positive coordination sphere. Make a note of this while doing IUPAC nomenclature. So we understand that this is positive, like there are 3 potassium, 1 potassium has +1, 1 potassium has +1. So 3 potassium contributes to, this potassium contributes to +3 of the charge. 3 potassium means it is this way. 3 into +1, which is equal to +3. If this is +3, then this should be -3. That's why this is negative coordination sphere. So trioxalato aluminate. Writing the word aluminate. Now inside this, you are writing the oxidation state. After this, the name doesn't end. We also have to write the oxidation state at the end on the aluminium. So I'll form the equation for this. Like you can do it, write it completely, or you just consider this as a coordination sphere inside this. There are different way. You consider the potassium and equate that is equal to 0 while we form the equation. I'll put aluminium as X. I'm finding the oxidation state. I'm putting that aluminium as X. 3 oxalate ion, 1 oxalate has -2 of charge, which is equal to this charge, which is equal to -3. So X minus 6 is equal to -3. Therefore, x is equal to minus 3 plus 6, x is equal to plus 3. Now you can also find this oxidation state. Some students have the habit other way of finding the oxidation state this way also. This is also fine, means you consider it continuously. You consider the potassium also. If you are considering this potassium, don't consider this negative sign, put it is equal to 0, because total charge after combination will be is equal to 0, cations and the anions. So I'll write that also over here. Still the answer will come same. So 3 into plus 1 on the potassium, aluminum I'm putting as x, 3 into minus 2 equals to 0. Instead of minus 3 I'm putting equals to 0, because I have considered this. Whichever method you are solving, stick to that one method. So 3 plus x minus 6 is equal to 0. X is equal to 6 minus 3, x is equal to plus 3. Means over here in this bracket you are going to write the Roman number 3, and this is what is the name of this compound. And like I will highlight this, what to write for the exam, what you are expected. This is the name, this is what is you are expected to write in an exam. Okay, this is the point, these are the points you should be knowing. These are the things you should be knowing, whether to write aluminate or aluminum, like chromium or a chromate. We have to name the ligand first, then central metal atom in a coordination sphere. Keep all these things in mind and do the nomenclature. Second, I'll write second part of this question. They have written what it is, chromium NH3 4, chromium NH3 4 H2O twice, and the counter ion is negative, chlorine Cl3. Okay, 1, 2 and 3 over here you may messed up with the whole question. So over here coordination sphere is first, right? You see this is the coordination sphere, this is first. So we'll start with the coordination sphere first. So again there is a ligand ammonia and water. So for ammonia is a neutral ligand. That is NH3. And as a ligand, what is the name of this? This is a amine. Okay, double M. This is very important. Double M. And water as H2O. Its name is aqua. Right. So two ligands are there. One is amine and other is aqua. So what will come first in alphabetical order? Obviously AM. M comes, like A and A is common, so I'll consider M second letter. The second letter is also common, I'll consider the third letter. So AM. So I'll write tetraamine. Start with the ligand tetra double M. This is very important. Single M when we write is IUPAC nomenclature of the organic compounds. Amines, there we do it single M. Here it is double M. If this word is derived from the ammonia, understand. Ammonia has double M. Tetraamine, then diaqua. Why diaqua? Two water molecules are there. And I'll be writing straight chromium. Why chromium and why not chromate? Can you comment it in the comment section? Because this is a positive coordination sphere, because there is 3Cl3. The contribution of this will be 3 into minus 1, which is equal to minus 3. So this is plus 3. Positive coordination sphere, that's why. Therefore, plus 3. Right? Therefore, chromium, I mean. I have to write the oxidation state also over here of the chromium. Let's find that. So I am taking this as X, taking this chromium as X. 4 into ammonia is 0, plus 2 into water is also neutral, equals to plus 3. Therefore, X is equal to plus 3. Means in coordination sphere, the answer will be plus 3. Then outside the coordination sphere, what is there? There is a chloride ions. It is not chlorine, it is chloride ions. chloride. Three chloride are there. I mean, when it split, it will split as 3Cl minus ion chloride. This is what is the name of the compound. And this question was for 2 marks, one for writing, like 1 mark for each IUPAC name. And IUPAC name in nomenclature is very simple. What happens in the topics of the physical chemistry, you require some time for the calculation, writing the formula, figuring out the concept. But here things are very simple. If you know the names of the ligand, how to name them, you will easily get these marks. Next question is, on the basis of valence bond theory, deduce the type of hybridization. What is asked is that you need to find the hybridization and the geometry of the high spin complex. They have said that it is a high spin complex. See, geometry directly, it is when the coordination number is 6. Okay, geometry, understand this. When coordination number is equal to 6, geometry is what? Geometry becomes what? Geometry is always octahedral. Octahedral. Okay, but sometime what happens if the coordination number, you have to take care over here. Coordination number is equal to 4. Then there are two possibilities for this. There are two possibilities. One is square planar, one is planar, square planar, and other is tetrahedral. Other is tetrahedral. But over here the hybridization will matter. Here for the tetrahedral, sp3 hybridization if you are getting, then the tetrahedral. And if the hybridization is dsp2, then it is what? Square planar. So you have to take care of this hybridization. Again, that will depend upon the type of ligands what it is connected. So this is the thing. So we'll find the hybridization and the geometry we know surely it is a octahedral because coordination number is 6 over here. So we'll write for this. I'll start with the thing. So cobalt, the complex is cobalt F6 3 minus. Cobalt F6 3 minus is the complex. Now if you write the electronic configuration of the cobalt, we'll write the electronic configuration of the cobalt. Cobalt's electronic configuration is argon 4s2 3d7, right? This is what the electronic configuration of the cobalt means. I will write over here cobalt, and cobalt, what comes is 3d, not with respect to energy, but third shell comes, the quantum number is low for this 3. This is 3d 4s and 4p. Right. So cobalt, I'll write the electrons over here. I have the freedom to use different color. You will not have. You will have just blue pen in an exam. So I'll write 7 electron. 1, 2, 3, 4, 5, 6, 7, and 2 electrons in this. Now, what is the oxidation state of the cobalt? What is the oxidation state of the cobalt over here? So what is the oxidation state? We'll find it out. The oxidation state of the cobalt, I'll put this as X plus 6 into minus 1. 6 into minus 1, which is equal to minus 3 is the charge on this coordination sphere. Therefore x is equal to what? Plus 3 means cobalt is in plus 3 oxidation state. Let's see, CO plus 3. Plus 3 means you are going to remove the outermost 3 electrons over here. So now I'll write this set again. I'll just show this set. So which 3 electrons we are going to remove? We are going to remove these 2 electrons from here, and the 1 electron which was the last electron which went there. This is that last electron which went over here, right? So this is the thing. Now understand that a fluorine is a weak field ligand. Now fluorine is a weak field ligand. So what happens? Pairing happens for a weak field ligand, or pairing doesn't happen for a weak field ligand. So I'll write over here cobalt 3 plus in this complex, same complex, Fe F6 3 minus. Now you tell me, since fluorine is a weak field ligand, is it going to pair or not? Understand, for a weak field ligand, again you have to remember, for a weak field ligand, where shall I write? I'll write it here. For a weak field ligand, pairing does not take place. Pairing no pairing takes place. No pairing takes place. Pairing of electron take place. And for strong field ligand, pairing takes place. So over here, this is a weak field ligand. So here pairing is not going to take place. Means I'm going to write this as it is. Write this as it is. Right. After 4p, what will come is a 5d. Sorry, 4d, I mean 4d. Okay, 4d orbital. 4d orbital, which is empty. So here I will require this, because now there are 6 ligands, and the ligands of the fluorine, I'll show that with the blue color, means electrons involved in a coordination, because coordinate covalent bond is the bond where both the electrons are from the fluorine, right? Or the ligand, I'll write. So these both blue electrons are from the fluorine. So one fluorine, second fluorine, third fluorine, fourth fluorine, fifth and sixth. So what is this hybridization? Like this is from F minus, this is from F minus, F minus, F minus, F minus, and F minus. What is this hybridization? If you see over here, which orbitals are involved? There is one orbital, of what S, 3 orientations of the P and 2 orientations of the D. So what hybridization it would be? The hybridization would be this way. This is the hybridization. S, P3, 3 orientation of, and sp3d2. Okay, this is the hybridization which is asked in a question. But other questions with respect to this same thing will be whether the given compound is paramagnetic or a diamagnetic. You see that there are so many unpaired electrons over here. Okay, there are so many unpaired electrons over here. So that's why it is paramagnetic. Paramagnetic means just one, even if one unpaired electron is there, then it is paramagnetic. So many questions could be formed based on this one simple thing. So hybridization is sp3d2. You will write answer as a hybridization. This is your answer. This is your answer which is asked as a hybridization. And obviously geometry is what? Geometry is sp3d2. This is what the geometry is. Okay, so finally what you are writing, showing all this workout over here, how you have got this. Okay, simply writing the answer, you won't get the marks because they have mentioned clearly over here, on the basis of valence bond theory, deduce the hybridization geometry of the high spin complex. Here is the next question, similar question like the previous one, but over here the coordination number is uh, 4. Means there are two possibilities of the hybridization. One can be, uh, it means two possibility of the hybridization was there also. There was like in coordination number 6, sp3d2 or d2sp3. Here also there are two, but here there are two possibilities of the structure. One can be square planar and other can be tetrahedral, right? That is what I discussed over here. So we'll go ahead with this. We'll try understanding. So these questions are very simple. If you can figure out over here the hybridization, you can easily say about structure. Okay, they have also mentioned a tetrahedral complex. They have directly mentioned a tetrahedral complex. The question is further two, on the basis of valence bond theory. See, understand, tetrahedral means the hybridization should be sp3. Okay, we have to figure out what is a magnetic character over here. We'll go step by step. So nickel carbonyl is the compound. I'll write the electronic configuration of the nickel. We'll first write the electronic configuration of the nickel. Nickel is, the previous one was also nickel, right? Sorry, that was cobalt. Nickel is 28, no? 28. So 4s2, the electronic configuration is, atomic number for the nickel is Z is equal to 28. 28. So configuration becomes argon 4s2 3d8. Right? So we'll write for the nickel. For you to understand this nickel configuration, first I'll write 3d. Okay. 1, 2. Then it is 4s and then 4p. So nickel's configuration, to do it very systematically to get full marks for this. There are 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, and 2 electrons over here. Now what is the oxidation state of the nickel in a nickel carbonyl complex? Over here they did not mention any charge on this. This is 0, right? So what will be the charge? We'll calculate on this nickel. X plus 4 into carbonyl is also 0, right? Which is equal to 0. So X is equal to 0 means it is not in any of the oxidation state. Now you directly write, instead of writing that compound in any other oxidation state, it is in 0 oxidation state. So nickel in, I'll write nickel tetracarbonyl 0, right? 0 is the oxidation state. So what will happen? Carbonyl is a strong field ligand or the weak field ligand? The carbonyl is a strong field ligand. Carbonyl is strong field ligand. So pairing is going to take place, right? Pairing is going to take place means over here the electrons which you are going to pair up is this. These are the electrons which are going to pair up. There were 8 over here, and these two will come over here. Now, the 4 ligands of the carbonyl will start from here: 1, 2, 3, 4. So this is carbonyl, this is carbonyl's electron, this is carbonyl. So what is this hybridization? This hybridization becomes what? 1 of S and 3 orientations of the P. And it should be sp3 because they have mentioned, no, it is tetrahedral complex. So hybridization is sp3. So answer becomes what? Hybridization is sp3. Magnetic character, you see that none of the electrons over here, are paired, or over here it is paired. So what we'll write is that magnetic character is a diamagnetic. Magnetic character diamagnetic. Understand what is a man? Like for those students who don't know what is diamagnetic and paramagnetic. Paramagnetic means presence of at least one unpaired electron. Okay, more than one is possible, then also it's paramagnetic. Diamagnetic means all electrons are paired. Next question. The coordination number of the cobalt in En3 is, like, coordination number over here means how many connections are there over here. So what is En? En is the ligand whose name is actually ethane 1 comma 2 diamine. This is what En is. Okay, like if you want to know the structure, ethane 1 2 diamine, it is this: CH2 NH2 NH2. So there are lone pair of electron over here. So one ligand forms two linkages. One ligand has two linkages. So this is didentate ligand. Coordination number is asked. Coordination number of the cobalt En, that is what is asked. So one ligand has three linking sites. Sorry, one ligand has two linking sites. So total will be what? Total coordination number over here will be 3 into 3 ligands into 2 is the denticity, which is equal to 6. So the answer becomes 6 over here. This is what the answer is. Draw the structure of geometrical isomer. Draw the structure of geometrical isomer of FeNH3 twice and CN6 4 minus. So geometrical isomer, when we say geometrical isomer, that is, we are talking about the cis or the trans isomer. So this type, it is what? It is a metal it is of the type A4, sorry, A2X4. This is of the type this is possible. So how I will write this is iron. This is, there are 3 NH3 ligands are there. This 3 NH3 ligand, I'll place it this way. which represents they are in one plane. This is NH3. This is, sorry, there are two NH3. Okay, and there are four cyanides. I'll put this four cyanides over here: CN, Cn, and Cn. If you go to see all these four cyanides and one ion over here, they are in one plane. Okay, and I can put two NH3 like this, one above the plane and other below the plane. Other below the plane means it is as good as this. You have one plane. I'll try to draw that plane over here. Let's say this is that plane. Okay, this is the one plane. Okay, and here is your Fe, here is your Fe, here is your cyanide, here is your another cyanide. This is cyanide, this is cyanide, and this is what the real bonds are. These are the real bonds. And this one NH3 is on the top of this plane, and another NH3 is below this. Okay, so this is the thing. This is a trans isomer. This is a trans isomer of this. So draw the structures of geometrical isomers. So trans you have to mention, and what would be cis? Cis will be also similar. Cis will be also similar, but what I'll do is I'll put two NH3 on the same side. I'll put this NH3. They are on the same side, and this is cyanide. This is a cis isomer of this. Using valence bond theory, deduce the hybridization of the inner orbital complex FeCN6 3 minus and comments on its magnetic property. FeCN6 minus. So complex given is FeCN6 3 minus, right? Yeah, this is what the complex, and you have to find what you need to find. Comment on its, deduce the hybrid. We need to find the hybridization. Also, they have mentioned inner orbital complex. Hybridization and the magnetic property. You need to find the hybridization. Hybridization and magnetic property. Understand, student, that over here, whenever the coordination number is 6, hybridizations are what? sp3 sp3d2 or d2 sp3. This is called as outer orbital complex. Outer orbital complex. And this is called as inner orbital, because here inner d orbital is taking part, here it is outer or d orbital is taking part. Inner orbital complex, right? They have mentioned that over here it is inner orbital complex, so the hybridization should be d2sp3. We'll figure it out. So over here, I'll write the configuration of the Fe. Ion configuration Z is equal to 26, right? Z is equal to 26 over here. So it is 4s2. Configuration is argon 4s2 3d6. This is what the configuration is. So I'll write for Fe first. um, it is 3D. 1, 2, 3, 4, 5 orientation, then 4s, then 4p, okay. If required, we'll put 4d also if required. I don't think so, since it is inner orbital complex you will require this outer one. Okay, simply don't waste time. So over here there are two electrons, and this is 1, 2, 3, 4, 5, 6. So what is the configuration of the Fe in FeCN, sorry, oxidation state of the Fe in a FeCN6 minus? So I'll put this is equal to X. I'll put this is equal to X plus 6 into minus 1 is equal to minus 3. X minus 6 is equal to minus 3. X is equal to plus 3. Means Fe is in a plus 3 oxidation state over here. Fe is in plus 3 oxidation state. So you are going to remove some electrons. You are going to remove some electrons. So which are those? So you are going to remove the electrons this way. This one, 2, and the electrons which entered last. So electron which entered last is this one, the pairing electron. Then this, sorry, you have to remove 3 electrons. So you are removing this 2 and this is 1. So this is done. These many electrons you are removing. So now if you see CN6, what is CN? CN is a strong field ligand. If you refer to a spectrochemical series, CN is a strong field ligand. Since CN is a strong field ligand, the pairing will take place. So you will write Fe in FeCN6 3 minus. So over here the pairing is going to take place. So what pairing is taking place over here? There are 5 electrons, 1, 2, 3, 4, 5. This is last is not required in this case. For outer orbital complex only it is required. So now you have 6 ligands of the CN6 minus. I will show this with the blue color. 1, 2, 2, 3, 4, 5, and 6. So what is this configuration? This configuration is D2sp3. Why? You see over here the hybridization, like this is from the, like you should write this, Cn minus, this is Cn minus, Cn minus, Cn minus, Cn minus. So this hybridization over here will be D2sp3, and it should be D2sp3 because it is mentioned in the question that it is inner orbital complex. We have to find a magnetic property. What is the magnetic property? So we got hybridization as that is what was asked. Hybridization is what? D2sp3. And magnetic property, please comment and tell me. You see that there is one unpaired electron over here. So magnetic property becomes paramagnetic. Paramagnetic. That's it. That is what the answer is. So this question, the coordination number and the oxidation state of the central metal atom in the complex is given over here. Um, complex is chromium complex. chromium, there are, this is also known as a heteroleptic complex because different types of ligands are there. Two different types of ligands are there. And the counter ion is a sulfate. Okay. So what is asked? The coordination number and the oxidation state. Over here, there are how many ligands? This question is about with respect to coordination number. There are five ligands. There are five ligands. This ligand is also unidentate. Unidentate means only one linking site. And this ligand is also nitrate, sorry, nitrito. That is also unidentate. Means one from here and five from here. So total coordination number will be what? Coordination number will be 6, right? And the oxidation state I need to find. So coordination number will be what? 5 plus 1, which is equal to 6. And oxidation state, I'll put this as chromium as X plus 5 into ammonia is 0. Nitrito, NO2 minus. There is minus 1 charge is there. So only 1 is there. So 1 into minus 1, which is equal to, this sulfate is minus 2. Always remember. In H2SO4 also sulfate is minus 2. So what should be this? This should be plus 2. So therefore this coordination sphere, charge on this coordination sphere is equal to plus 2 I am putting. If you are considering the sulfate also, then you will write minus 2 equal to 0, right? So over here X is equal to X minus 1 is equal to plus 2, X is equal to plus 2 plus 1, X is equal to plus 3. Means 6 comma 3, 6 and 3. This is what your answer is. Draw the structure of the optical isomer of the chromium complex which is given. This is what the complex given. Write the formula of the amine bromido, chlorido, nitrito, N platinate 2. So one amine is there. Okay, all the ligands are one ligand. Okay, first we'll handle the first question, first part of this question, which is, see, there are two isomers for this. There are two isomers for this. What is asked is the optical isomer, right? So I'll first draw both the isomers, and I'll tell you out of this which one you should write or draw for the exam when such type of question is asked. So I'll write chromium. Now what is ox? Ox is oxalate, or the oxalato is the ligand. As a ligand we write oxalato, and ox is standing for this CO, O minus, C double bond O, O minus. So this is usually a didentate ligand. This is a didentate ligand. Okay. Means in short we write that as ox. It will have two linking site. So over here I'll write the chromium. One possibility of the ligand is this way. First we'll draw, like coordination number is 6. I'm drawing all the 6 ligands connected to it. How do I understand? Ox is 2 ligands are there. So this coordination number will be 4 and this will be 2. Total is 6. So all its coordinate covalent bond. So I'll write ox this way. This is our ox ligand, oxalate. This is our ox ligand, oxalate. And this is Cl and this is Cl. Now the structure is not the way how it is not a planar structure. As explained earlier also, this structure is something this way. This structure is something this way. Means if I want to consider that This is the chromium. The structure is this way. Chromium, this is in one plane. This is in one plane. Chromium, ox. This is above the plane and this is below the plane. Means, to be more precise, I'll just replace this with a ox with a like triangles. This is one triangle over here. This is another triangle. Okay, just consider this as one triangle. And this is the plane. This is another triangle. Okay. And this is chlorine and this is chlorine. Like this tells you about the ox. And this is the linking side. This is the linking side, right? So these are the two linking sides. Means over here, this is what the structure. I'll call this as a trans isomer of this. This is a trans isomer of this. What would be a cis isomer? The cis isomer of this, cis isomer of this would be, I'll draw first this way. Hope you are understanding that it is these bonds are in plane, whether it is didentate or bidentate. I'll write these two as oxalate, and these two as ox, and this is chlorine and this is chlorine. Okay, now you understand how is the structure. This is the one triangle, this is our chromium, and this is the triangle. Okay, like if I want to draw the triangle, I'll first draw the triangle, or we'll consider, like for me drawing the square is easy. Like this is one square, like you consider that this is in one plane. Okay, this downside while I am writing this way, this is in a different plane. See, I'm trying to try visualizing it. These are like a two planes mutually perpendicular, and this is chlorine and this is chlorine. Means this is your ox, this is your ox. Now this is your ox. Over here, this is your ox. Getting? So here there is, you pass a plane, any plane you pass, there is no plane of symmetry in this molecule, because you don't get the same image over here on the both the side. Here no plane of symmetry, no plane of symmetry. Okay, there is no plane of symmetry. Here in this case, there are two planes. You pass a plane through this, you pass a plane through this, or you can also pass a plane through this. So whenever there is a plane of symmetry, it is optically inactive and you are not writing. So this compound is optically, this structure is optically inactive. This is what is not asked. This is what is not asked, optically inactive. Because there is planes of symmetry or symmetry element, plane of symmetry. This compound. So you have to write this as the answer, this structure you are drawing. Okay, this is the structure which you are drawing. Write the formula of the amine. Okay, formula of the amine. Take this question down. There are so many ligands in this question. So formula in the ligand, this is amine is there, bromido is there, chlorido is there, nitrito and platinate ion is there. Means this is surely a platinate they have written, means negative coordination sphere. And they have written ion. So we'll write. I'll write the coordination sphere first. I'll write the coordination sphere first. There is platinum. Okay. I'll write amine. You don't have to be in alphabetical order. Amine is there. Bromine is there. Chlorine is there. And nitrito N. Whenever it is nitrito N, it is NO2. If it is nitrito O, then you would have written ONO, nitrito NO, because nitrito is a ambidentate ligand. It can link through nitrogen or it can link through oxygen. Here nitrito N means it is linking through nitrogen, nitrito N. And they have written platinate. They have written platinate. And ion. So we have to write the oxidation state. We need to find this X. We need to find this X also, and we have to write over here. So platinate means negative coordination sphere. So I'll write platinum. They have written that platinate. Instead of putting X, I am finding this X. Right, will form the equation. I know that this platinum is what? 2. So I'll write this 2. Ammonia is 0. Bromine is -1. Plus chlorine is also -1. Plus NO2 is also -1. Which is equal to X. Because I don't know this X. So 2 -1 -1 -1 is equal to X. Right? So X is equal to -3. Therefore X is equal to -1. Means over here the charge will come to be is equal to -1. This is how you need to do this. Next question, state the oxidation state and a coordination number. Okay, this is again very simple question. State the oxidation state and the coordination number of the chromium. Oxidation state of the chromium will be what? We know X is equal to ammonia is, there are 5 ammonia and it is neutral. There is 1 bromine which is having -1 equals to the charge is +2. So X plus 0 -1 is equal to +2. X is equal to +2 plus 1. Therefore X is equal to +3. Means oxidation state of oxidation state is what? State is +2. And coordination number is 5 plus 1. Coordination number should write full form, not short forms, is equal to 6. 6 ligands are there. Deduce the structure using valence bond theory. Deduce the structure of the, you need to know the structure, because since ligands are 6, the structure is surely octahedral, but they have said using valence bond theory, so you have to go through the process. Nickel CN6 2 minus. Have I done that example before about the valence bond? Yeah, here it is 2 minus, this is 3 minus, sorry, where it is, yeah, 2 minus. What you can do at this point, if you are watching this video till here, till this point, hats off to your dedication, I would say. But if you're watching this video, please you try doing it. Okay, you try doing it and send me the answer. And if you still have the difficulty, I'll explain that to you. Okay, because this type of examples I have done so many, so I don't feel point in doing this again and again, this type of things. Using valence bond theory, deduce the structure of nickel CN4 2 minus. Coordination number is 4. Have I done any coordination number for CN4 2 minus? 1 minute, I'll just check. It is carbonyl, right? It will be going same as CN4 will be same as carbonyl because both are strong field ligand. Both are strong field ligand. This will have same same hybridization, same properties like nickel tetracarbonyl 2 minus, which I have done it over here. That is the tetracarbonyl. But over here charge was 0. Okay, I'll do this for you, not an issue. Not same, it will be slightly different because the charge is 0. I'll do this. Nickel's electronic configuration, Z is equal to 28, so 4s2 3d8 argon. This is what the electronic configuration is. So nickel, I'll write first. Nickel 3d 4s 4p. Maybe only this much is required till 4p for a coordination number 4. Nickel is in what oxidation state? I need to find it out over here. So oxidation state of the nickel in carbonyl is what? X plus 4 into carbonyl is neutral, which is equal to -2. Sorry, this is CN6. No, sorry. CN4. CN4. So this is equal to X plus 4 into -2 is equal to -2. X minus, this is Cn is -1. Sorry, this is -1 equal to -2. X is equal to +2. Nickel is in +2 oxidation state. So we are going to remove, first we'll write the electrons what were present in the nickel. So 2 electrons over here, 1, 2, 3, 4, 5, 6, 7, 8. And after removing these 2 electrons, you will be writing it this way. So 2 electrons, you are removing these 2 electrons. So you are writing these 2 electrons you are removing in +2. 3, 4, 5, 6, 7, 8. Now nickel in nickel CN4 2 minus. Cn is a strong field ligand, so pairing is going to take place over here. So 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So there are 4 ligands of the cyanide. 1, 2, 3, 4, 3, 4. 1, 2, 3, 4. So this hybridization over here becomes DsP2. This is the hybridization of this. One orientations of the D, one orientation of S, and 2 orientations of the P. So if hybridization is this, comment on the geometry, structure. So over here, since hybridization is DsP2, the structure will be what? Structure is square planar. Structure is square planar. Draw the structure of optical isomer of platinum complex. Deduce the hybridization scheme for the outer orbital complex. Comment on its magnetic behavior. So optical isomer means optically active. Okay, there are two possible isomers. I'll draw this again. This is like a similar example which I have done previously. So one possible isomer for this complex is 2En, another En this way, one chlorine on the top, one chlorine below. Here 2En this way, ethane 1,2 diamine. This is chlorine over here, it's chlorine over here. So optical isomer. This is the optical isomer. This one means you don't have to draw this. You have to draw this. This is optical isomer. Since there is no plane of symmetry, this is the structure which is expected from you. Then COF6 3 minus hybridization. We need to find the hybridization and the magnetic behavior of this. COF6 3 minus. Cobalt's configuration Z is equal to 27. Configuration is argon 4s2 3d7. So I'll write the cobalt configuration over here. First will be 3d, 1 2 3 4 5, 4s, 4p, right? 7 electron, 1 2 3 4 5 6 7, and 2 electrons over here. Oxidation state of the cobalt over here is x plus 6 into fluorine is minus 1 is equal to minus 3. X is equal to plus 3 means I am removing 3 electrons from there. So which are those? These two and this 1 electron, not this 1 electron I am removing. So 1 2 3 4 5 6, this is the thing which is remaining at the end. Now we'll require this. So fluorine is a weak field ligand. So whenever it is a weak field ligand, pairing doesn't take place, right? I have to write 4d also over here, because some of the orbital of this d I will have to use. So I will write cobalt in COF6 3 minus. One, two, three, four, five, 6. So F minus, there are 6 ligands of F minus. I'll put it this way: 1, 2, 3, 4, 5, and 6. This is F minus, F minus, F minus, F minus, and the F minus. So what is the hybridization? Hybridization is sp3d2. The question is about, yeah, it is outer orbital complex sp3d2. magnetic behavior. Hybridization is sp3d2, and magnetic behavior is there are so many unpaired electrons over here. Therefore, magnetic behavior is paramagnetic. Okay, if this video has added value to your preparation, given a boost to your preparation, please like, share, subscribe, share with your friends, give as much as love possible to this channel. Thank you so much.